Example 3. We need to prove that the set of parametric equations x equals h plus r cosine t, y equals k plus r sine t, okay, represent the circle or a circle with, centered at hk with radius r. Okay. Do you remember what the equation of a circle with a circle center at hk with radius r looks like? Keep going.
X minus k squared.
Almost correct.
X minus h squared plus y minus k squared equals
That is correct. What you said. What Manny says is a circle with radius r centered at hk in Cartesian coordinate xy, read the quantity x minus h squared plus the quantity y minus k squared equals r squared. So whatever we do, this is our target to show that this is what we end up having. So we're going to start by setting up x squared and y squared and then add them up. Okay, so x squared by itself, if you square h plus r cosine t, then you end up having h squared plus 2hr cosine t plus r squared cosine squared of t. And likewise, if you square y, you end up having k plus r sine t squared, and as you clear the parentheses, you end up having k squared plus 2kr sine t plus r squared sine squared t. Okay, and now what you want to do, you want to add these two equations together, right? So put a plus here and get x squared plus y squared, and let's add them up. But I'll add them up from here, okay? So we'll put the plus sign right there, and we have h squared plus k squared. And then we have 2hr cosine t and 2kr sine t. And then we have r squared times cosine squared sine squared, right? But you know that this is going to be r squared as you add r squared cosine squared and r squared sine squared. Okay, you okay with that? Yes? No? Quiet. Anybody does not see why I have r squared here? You don't. Okay? So let's write it cosine squared t plus r squared sine squared t. Okay? And now, let's do the following. So it would be h squared plus k squared, right? Plus, I'm going to move r squared, and if you factor, you have cosine squared plus sine squared. Well, this is equals to 1, right? And then you have the 2hr cosine t and the 2kr sine t. Okay, so at this point I have h squared plus k squared plus r squared plus 2hr cosine t plus 2kr sine t. And this is what I'm going to do next. Since I can read into the future, I have this ability to look at the future, and I'm going to do something like this. I'm going to first have r squared. And then instead of h squared, I'm going to write 2h squared. Okay? And instead of k squared, I'm going to write 2k squared. So I added h squared and I added k squared, right? So immediately I need to subtract one of each. And then I have plus 2hr cosine t plus 2kr sine t. Now remember, this is all equal to x squared plus y squared on the left. So, well, I'm not there yet. I have one more thing to do. I'm looking at 2h squared, and I'm looking at 2h. So I'm going to factor the 2h, right? And I have h squared, actually, not h squared, just h. And then I have plus r cosine t. Okay? Now, I'll do the same thing. I see that I have 2k squared and I have 2k. So I'll factor the 2k. So I'll have 2k, and from here I have k, and from here I'll have r sine t. And let's collect what's left. What's left is minus h squared minus k squared. Now, if you watch carefully, what is the quantity in the parentheses right here? H plus r cosine t. X. And likewise, the quantity k plus r sine t is y. So, going to the next page, I can write x squared plus y squared equals r squared plus 2hx plus 2ky minus h squared minus k squared. I tell you what, I'm going to move everything except r squared to the left side. Okay? So, I'm moving everything but r squared to the left side, and I have x squared, and next to it I'll have minus 2hx, and then I have plus h squared. Okay? From here. And then I have the y squared minus 2ky plus k squared. And all of it equal r squared. Okay? And I'm looking at this trinomial, and I'm looking at that trinomial. And as I read carefully, I can see, wait a second, this is nothing but x minus h squared. And here is y minus k squared. And this is r squared. Okay? And this is the equation of the desired circle. And this, my friend, complete the proof. So we had a little trick here. Just take h squared and k squared and add and subtract h squared and k squared. So to get 2h squared and 2k squared.